Hello everybody, it's wonderful to be back with you here today and learning GIS. I am Dr. Seema Mehra Parihar, who has been teaching this paper now for last 30 years. Have had my share of learning of GIS also from IIRS Dehradun. Have got my PhD from Delhi School of Economics, Department of Geography, University of Delhi, and have my postdoc fellowship from ITC Netherlands. So, let us move ahead and learn a little bit about the spatial analysis. The objectives of today's lessons are the following. Number one, we will learn about the concept of spatial analysis. We will understand various types of spatial analysis in geographical world. We will also learn the detailed description of proximity analysis and buffer zonation. That something is the aim of this chapter. So, by now we all are very clear about what is GIS. GIS is something that deals with the locational information. GIS is something that dealing with the capturing data from the real world. It is not only providing the image and visualization of the real world, but it is also helping us in planning the future prospects, glamorous, aesthetic and useful world, and that something is the major advantage of using geographic information system as a tool for decision making. We all can today make lot of interactive maps, but all these things are only possible because we are making and using this GIS as a tool of analysis. Today there are different software, and these software are taking us forward in performing different analysis. We have got proximity analysis, which we are going to do in this chapter in detail, which talks about the distance functions, which talks about the neighborhood functions. You remember now when you all are going from this place to this place, which is the shortest route and all that falls into that. Then we will also be talking about the buffer analysis. That means we are talking about the point buffers, we will talk about the line buffers, we will also talk about the area buffers, and that is something which is so very important. And in geographical analysis, what we find is that it allows us in understanding and interpreting the spatial resource space. There are different models for it, and these models illustrate various trends in geographical data. And thus, as a result, what happens? Yes, you are right. This will convert data to an information, and the moment we combine all these, we come with the new model, and these new models may reveal now or previously unidentified relationships within and between data sets, thus increasing our understanding of the real world. So, I think so it is clear, it is analysis of all that data which we have captured. Let us now move forward and understand the concept of spatial analysis. Spatial analysis is related with geographical analysis that explains patterns of human behavior and its communication in geographical space in terms of locational analysis. That means we are talking about the mathematics and geometry and mapping and so on. For example, there is a nearest neighborhood analysis, and we have got Cartesian polygons. There are many models which are grounded in geography and microeconomics that are useful to predict the spatial patterns. For example, the growth of networks and urban systems, movements of goods and services, interpolation of rainfall, number of preconditions such as isotropic plane, movement, minimization, profit maximization, etc. That means even this GST which has been recently introduced, we all can find out that whether it will work in the pan India or not. Even the new scheme which the Prime Minister has launched in the form of the electrification of all rural villages, whether that will happen by 2019 or not, we all can spatially see that. And the figure which we have just in the adjacent block talks about the expression of different features in the industry. So, spatial analysis can tell us, can overlay so many layers and can talk about the topological references, geometric or geographical properties, their interrelationships and so on. It is so interesting, and these technique I want to tell you applies in attribute or feature structures, or and all is at human scale or your project scale, whatever you want. So, the spatial analysis is used for the procedure to produce the additional locational or geographical information to enhance the spatial expressions. Are you understanding spatial expressions? Yes. Structures and relationship between these expressions and all those attributes which we have overlaid. And there is a strong link between humans and the environment and spatial analysis techniques and methods which help to incorporate spatial elements into studies, so that we develop a cleaner picture of man-environment relationship. Isn't that something which we all want? And that is what even the related figure talks about. So, now we understand that GIS answers so many questions. Like GIS answers us the question every time we want to know about the where. So, GIS describes this question, then GIS data analysis answers the question why is it there. GIS analysis is the process of deriving information from one or more layers of spatial data. That is what the DMA says. So, it can involve multiple steps. Obviously, in case if it is answering so many questions, it involves multiple steps and processes, and it is perhaps the most important capability of a GIS, for which it has become so powerful today. So, after understanding that GIS is capable of answering so many questions, let us now get into the type of spatial analysis in geographical world. In GIS world, there is a variety of spatial analytical tools, and these are available, and these are there so that we can make our learning of the spatial base easier. And for this, of course, we use various analytical procedures. Wallace in 1997 and Shao in the same year, they included two types of operations in spatial analysis. One was single layer operations, and single layer operations are the ones which correspond to attribute queries, spatial queries, and alterations of data that operate on a single data layer. Then the second is we have multiple layer operations. These are useful for manipulation of spatial data on multiple data set layers. And spatial modeling involves the construction of explanatory and predictive models for statistical testing. Then we also have point pattern analysis. They deal with the examination and evaluation of spatial patterns and the processes of point features. So, similarly, we also have network analysis. Network analysis are designed specifically for line features, organized in connected networks, typically applies to transportation problems, locational analysis, drainage analysis. Then we also have surface analysis. They deal with the spatial distribution of surface information in terms of a three-dimensional structures. So, in addition to that, we also have grid analysis. Now, grid analysis involves the processing of spatial data in a spatial regularly space which are overlaid the boundary analysis, proximity analysis and buffer analysis. So, now we have learned the name. So, let us talk about the spatial analysis models, and these are based on both the models, and of course, you have learned this in detail. What are these two models? Yes, raster and vector. So, GIS functions are all based on these two data models. The raster data model, as you know, supports a wide variety of analysis, and the methods which are included in that are neighborhood operations, connectivity functions, query, classification and measurement functions. Similarly, you also have many spatial analysis which are formed on the vector based data, and they are called the vector based analysis, and they are little different of course with raster GIS. There are more operations that deal with objects and measurements, such as area have to be calculated from coordinates of objects instead of counting cells as in raster GIS. So, of course, they are different. According to D. Myers, vector system involves most of the time the analysis which are direct searching the database. Compared with the raster GIS, some of the vector GIS operations are more accurate. For example, in case if I want to find out the estimate of area based on polygons which are more accurate than count of the pixels, and estimate of perimeter of polygon are also more accurate of course than the pixel boundaries on the edge of the zone. Then you also find that some are relatively slower and some are faster. Example, we want to find the path through the road network. Obviously, we will make it much more easier in case if it will be through a vector based data. The idea of a vector representation is that we represent objects in the real world by 3 elements, name them quickly: PLA, point, line and polygon in the GIS. You have become smarter. Now, by using a traditional kind of 2D coordinate system with a continuous number system for the coordinate values, we can obtain a very high resolution data, and that too very efficiently. Say for example, there are two numbers x and y. We have the location of a point and we can store that position to zillionth of millimeter in a database if we wish, of course, because computer we know is a garbage in and garbage out. So now, after learning this, let us now come to another learning, that is, what are the common GIS analysis functions? Common GIS analysis functions are as follows. Number 1, the measurements, that is we calculate the length. Number 2 are the perimeter and areas. Then proximity analysis, reclassification, neighborhood functions, overlay functions, terrain analysis, where we work with all statistical surface, spatial interpolation. Then we also have network analysis, and then we have the combination of all above analysis functions and many more. You name it, and GIS will help you in solving it. So what we can say is, if we use this tool GIS, it will make spatial measurements easy to perform. Spatial measurements can be the distance between 2 points, area of a polygon or the length or a line or a boundary, and calculations be of simple nature, such as measuring areas on one map, or more complex such as measuring overlapping areas of 2 or more maps. How do we measure Euclidean or straight line distance between the 2 points? Suppose we have to measure straight road that connect 2 villages, say A and B. So you can find out through different formula. Of course, you all remember your Pythagoras theorem. How can you forget that? You know, you got a square, b square and c square, and a plus b, the whole square means, and we get a result a square plus b square plus 2ab. We all have learned this. So the basic mathematics never changes. But out here, now the software developers have made our life easier. So in case you all have to know what you have to take out from the software. So this vector GIS measurements involve all those Pythagorean calculations, different algorithms as calculations given in the diagram. But this is something which software developer has already put in that. You only have to use it. So you have to know your task. And in raster GIS measurements, say we know Manhattan distance. This is the distance along raster cell side from one point to another. Proximity distance, concentric equidistant zones around the starting point. So you have the following in this raster. You got a Pythagorean distance, you got a Manhattan distance, you got a proximity distance, and so on. Now what we are going to do is, in this chapter, we are going to take little bit more of learning of proximity analysis. Proximity analysis, just remember it. The first law of geography is said to be, as Tobler said, everything is related to everything else, but near things are more related than the distant things. Thus, it is very common in spatial process, much analysis is utilizing information about the distances between objects or features in GIS. Of course, the ones which are closer to you, you are much more related because you have got multiple interactions with it. If I take it to another journey, your family, home, all those people who live with you are much more closer to you. And that is what the proximity is. And even in the resource geography or any other, you talked about the absolute distance, relative distance. So I think so we all agree with Tobler that anything that is closer to us, we will be having much more interaction. So there are many ways to assess the proximity between two locations, and GIS helps us in doing that. We spread functions, and this is something another way of representation of proximity concept, where the distances surface grows outward from the feature of interest. Obviously, it will grow outside. For example, say raster GIS model to show the spread of lava from volcanic vent. If the lava comes out, that lava will slowly go out. Industrial expansion outside the city node. So, you got so many examples I know which you all are also remembering, and you all are so very right. And sometimes it happens that we have got more, and no, we need to calculate the raw distances, and all this also can be calculated with the help of GIS software. And one of the very popular and widely used single layer operation in GIS includes the creation of new information based on the measurement of Euclidean distance. This operation is called buffering analysis or zonation, and it results in the creation of surrounding coverage of features or around a geographical entity or set of entities. What is a buffer? Say for example, this is a point, just how many 2 kilometers from the point, this is a line, 2 kilometers from of that line, this is a river, 2 kilometers from a river. So, that means we talk about the buffer, that buffer, and that is something which we are going to learn. So, what is it that we have finished? We have finished with which analysis? PA, proximity analysis. Now, let us come to BA, that is buffering analysis. So, buffering analysis is something where we are creating zones, and it results in the creation of surrounding coverage of features, one or another geographical entity. For example, we can find out the village location nearer to road. We can also analyze coverage of flooded area from stream by buffer zonation. Then the distances of faulting landscape if we want. There are so many questions where you want to have a buffer. And this type of analysis can be done through the proximity distance. We can also analyze coverage of flooded areas from the stream by buffer zonation. See the earthquake also, in case it occurs, the distance of faulting landscapes, of course we all can do it. Say now, in case you look at the figure, location of the two villages and the Euclidean distance from the road, we are clearly getting a, we can get that and we can calculate it. Another figure which is showing us the faulting landscape coverage in interpolated region, and proximity analysis is one way of analyzing location of features by measuring the distance between them and other features in the area, and the distance between point A and point B may be measured as a straight line or by following a networked path such as street network. For example, in a site selection scenario where a prospect is interested in building a manufacturing plant in the beach area, imagine they want to have a plant near a beach area. An important consideration might be distance from the interstates and the airport, obviously. A GIS user can simply click on the point location representing the site and the interstate exit ramp or airport to obtain an approximate distance measure, and once the distances are determined, other pertinent information such as water, sewer availability, or say price per acre and availability of labor and so on can be analyzed, because now we got all that falls into that lane, right. So, is it clear? So, that means just with one click, but remember what is the mantra? Mantra is that we have captured the correct data. That is very important, and accurate data. What is buffering? Buffering is a process of creating areas of calculated distance from a point, line or area or object. Buffer methods are very commonly used in desktop GIS, and buffering is a process of determination or determining a distance from a separate object, say a point, a separate line or a separate area. Buffer is the creation of a zone of a specific width around point, line and area. It is also referred as coverage feature. So, buffer is also referred as coverage feature. Buffering sometimes termed as a proximity process. For example, say you can create a buffer of a circular zonation encompassing 1 kilometer of your house to find the nearest retail store. Of course, you want to do that, or you are feeling hungry and you want to order a food and you just want to see how much, which is the nearest point within half a kilometer, you can find it. Buffer is very helpful in determining potential impacts of even floods or any other type of hazard or disaster and its impact nearby. And this analysis is also used to identify the neighborhood of ethnic group. Buffering can be helpful in cluster households of ethnic group. That is something which it can be done. And the recent earthquake of Mexico or any volcanic eruption, all this can be mapped. The area outside the buffer zone is sometimes referred to as a skeleton zone. So, what is the area outside the buffer zone called? It is called a skeleton zone, and buffering is a local operator, just remember that, and it operates on each object individually. In fact, it operates on individual elements, its nodes and line segment of an object, right. So, is it clear? Buffering is one, and then the skeleton object outside it. So, now let us talk about slightly about the types of buffering. As I said, it works on 3 elements: point, line, area. Let us first do the points. Point buffering. Point is the basic element of resolution in a GIS system, and in the point buffering, data involves the creation of a circular polygon around point of interest, and the radius of a circular polygon is termed as the buffer distance. The radius of the circular layer are fixed in all directions with specific unit, and if multiple points in the same layer are being buffered, then buffer distances of each point has to be specified, and if the value of a circular polygon is multiplier points or sum, the buffer zonation can be overlapped to each other. Is it clear? Of course, we know a circle has 1 radius, and we calculate that how much around that point we want. Is it clear? Yes, I know it's clear. So, now after point buffering, let us do line buffering. Line buffering is definitely different from the buffering point data, because line joins segment from 2 points and it can be made up of multiple segments. Line segments are handled independently of each other. Generally, line buffering is very helpful in measuring proximate distance from roads and river zones. It uses mostly for the utilities and transportation, and that is something so very important. Line is there and then you have a buffer. You got a river and you have a buffer around that. Let us now come to the polygons. Polygon buffering, area buffering. Buffering of polygon surfaces uses most of the similar concept used for line buffering. The significant concern of the polygon surface is it carries buffer only one side of the line that define the polygon. Say this is a polygon, the line outside. So, in polygon buffering, 2 options are available. The first one is outside polygon, which surrounds or contain the polygonal surface under consideration, and another one is inside polygon. Say this is this, and that's contained inside the polygonal surface under construction. Is it clear? Yeah. So, you've got a point buffer, line buffer and a polygon buffer. Let us now talk about the multiple buffer zones. A feature can also have more than one buffer zone. Agree? Because GIS deals with multiple layers, and a nuclear power plant may be buffered with distance of 10, 15, 25 and 30 kilometers, thus forming multiple rings around the plant and part of an evacuating plant. An example of the multiple buffer zone can be seen in a figure. And buffering of a point feature with distance of 10, 15, 25 and 30 kilometer, and variation or difference in the buffering can easily be done. This is a point 1, 2nd, 3rd, 4th and so on and so forth. So, the value of the buffer distances varies as per the requirement of the proximity, and the value depends on the analysis of different features or objects. For example, the value of a stream buffer sizes may vary. It depends on the intensity of adjacent land use. A map feature may have more than one buffer zone termed as ring analysis. For example, the range of mobile network visibility within 5, 10 and 15 kilometers. A nuclear power plant may also be buffered with a distance as an example given you before. So, boundaries of buffer zone may remain unbroken so that each buffer zone is a separate polygon. Just remember this. And these boundaries may be dissolved so that there are no overlapped areas between buffer zones. Data acquisition and manipulational techniques such as map digitization, photo interpretation and map transformation often introduce errors in the data leading to problems in buffering, right. So, now we are clear about the buffer. Yes, we know proximity. So, now let us talk about the application of buffers. Buffer zone is very essential for planning or regulatory purposes. It often treated as protection zone or the neutral zone. It is also very useful in resource allocation, as Anderson said. It also made use of the buffering to demonstrate the potential uses of the Swedish land data bank and so on and so forth. So, something which is so very important if you want to plan the demographic spacing of the people, or we want to construct a new area, we want to develop a new urban areas. We also talk about the rural fringes, we want to evolve the road networks, railway networks and so on. So, buffers can be helpful in future planning of urban growth. Connectivity and area can be included in urban expansion. Buffering is also important for maintaining and managing rule and regulation in retail stores and area planning. For example, government instructed that there will not be any liquor shop or smoking facility within 500 meters of temple or the college campus or school campus. One can easily find out. City planners can also inquire or check through area buffering how many locations inside the boundary of 500 meters are there. So, it is so very much important analytical tool which helps us in spatial decision making. Let us now come to second use, that is called a social plan. And a buffer zone may be treated as a neutral zone to maintain law and order in a region. For example, a mob is protesting against the system. So, police department can create buffer zone of 100 or 200 meters of area or building locations for the security purposes, or protesting mass do not turn into violence. Buffer zonation can also be created for the clustering of settlement on the basis of caste, ethnicity, culture, particular development of cluster and so on. So, that means for social decision making also it can be used. Another use can be site suitability analysis. So, you want to find out whether this site is suitable to have a particular industry or not, whether this site is suitable as a tourism site or not, or as an adventure sport destination or not. So, besides that, say it is an industrial park, and we may find out that within 2 kilometers of a national highway or not. So, in the 2 kilometer buffer zone of national highway, this becomes an inclusive zone. So, this is something which is so very important, and this helps us. As per the government instruction under Environmental Protection Act, say Wildlife Protection Act or other environmental law prohibited and upregulated the industrial process, construction, mining, etc., etc. Say the law says that within 5 kilometers or 10 kilometers of the national park, forest biosphere reserve and so on and so forth, you cannot have this or you cannot have that. So, that all those buffers can be constructed. So, that means these buffers are very useful. And we can have another example. Say we have got a oil and gas well drilling within 50 meters of the roads or highways, within 500 meters from streams, lakes, ponds and reservoirs, or the national forest policy construct. That means we cannot have all those things. Multiple ring buffering can be useful in stream network, and analysis of velocity of stream in a particular distance also helps us. Another use of this analysis can be seen, environmental planning. Town and urban planning department may set aside land along the edges of the streams to reduce the effect of nutrient, sediment and pesticides runoff, to maintain shade to prevent the rise of stream temperature and to provide shelter for a wildlife and aquatic life. So, the buffers can be this thing, but of course, there are some limitations also. It is not that it is so easy to construct. Generally, it is because the software enablers have done that, and we agree it is very important for the planning and the policy making, and also for protecting the environment. Sometimes, but this buffer becomes a barrier due to the physical nature of the earth's surface and the units used in buffering creation. The unit and value of the buffer creation will always be in mind with cause and the terms which are there. Say for example, it is a hilly region, of course there will be a problem, and each and every location or site should use wisely for the buffer creation, because in the buffering the value will differ from case to case, otherwise it can be overlapped in mapping. And during the area buffering, mind on the selection of the tool only for outside zonation and shape of the buffering used as per the requirement is so very important. In hilly terrain, which is having so many problem in that database, you have to think or be creative. Accuracy should definitely maintain of the buffering, and it depends on the quality of the spatial data available, which is always there. I hope you will agree with it. I am very happy that now the concept of buffering and the proximity is so clear to you. So, let us just recapitulate. before we complete the lesson, what all we have learned today? We all have learned the relevance of spatial analysis in GIS. CSTRAD, A we have learned. And we have learned that the spatial analysis in GIS is becoming as an emerging tool to understand the world and whatever is happening around us. We have also learned the proximity analysis, and our thoughts have strengthened that it's a very important tool to measure the distance in vector and raster data models and its application in buffering operations in GIS. Also, we have learned that buffering is very important nowadays because it helps on multi-purpose analysis like planning, security purpose, environmental hazard mapping, accessibility analysis, and so on and so forth. And do you know that these days institutional intelligence also uses buffer operations? And one of the interesting field of research is predictive and adapting buffering techniques, and many people are working on it. Since any improvement in these techniques can have a drastic impact on spatial query response times, much effort has to be put in the field in the coming future. So, my request to you is grow up now. Now you are through with your so many lessons of GIS. Now you just know this. So, start using GIS as a tool of spatial analysis. Enjoy doing GIS, creating buffers and performing proximity analysis. Thank you very much.